Hi, my name's Dan, and this video is one in a series of videos that I'm doing about memory cells in simulated digital electronics. A fairly simple circuits called bistables. And we're fairly late on in the short series. We're looking at a thing called a JK flip-flop, which gives us frequency halving. And in this video, I'm going to show you how to use this to create a simple binary counter. For the wider context of what's going on here, there's a long series of videos which go from the basics of simple logic gates to a 4-bit CPU computer, which we'll be able to program by the time we get there. So a roadmap of how that's been developed and where we're up to is in the description below, as is a link to this digital simulation software called DigitalWorks. And it's free to use, so feel free to grab it to do this. So in the last video, I described this particular kind of bistable circuit, which is called a JK flip-flop. I bemoan the fact that I can't make one work inside DigitalWorks, but I've used their built-in one. This is the only component that I'm going to use for this CPU that is not a basic one of the basic gates. And I'm going to chain a few of these together to show you how to build a simple 3-bit binary counter. Why 3-bit? Why not 4-bit? Actually, because somewhere way down the line in a future video, this is what I'm going to need, is the ability to count in 3 bits. So at the end of the last video, we had this circuit which has got the clock coming in, and it's got a single JK flip-flop, and it's doing frequency division. And so in order to get 3 bits here, I'm going to need to chain some of these together. So I'm just going to stop the simulation, and I'm going to get rid of that LED, and I'm going to get a couple more of these JK flip-flops, stick them in, and what I'm going to do is I'm going to chain from Q output from that one to the clock input of this one, and the same from there. Okay. And then I'm going to, so first of all, I will demonstrate it working, and then I'll turn it into a macro so that it can be used in the future. What do I need? I need plus voltage for both J and K of all 3 of these. It's not the most elegant bit of wiring up that I've ever done. And then I'm going to stick LEDs on the outputs for these 3. So I'm going to tap that one off the Q output from the first one. And this is going to come from the Q output of the last one. Okay. Hopefully, when that runs, it's counting in binary. Yeah, so our binary number is effectively reversed in that the least significant bit is at the left-hand end rather than the right-hand end. But hopefully, as you can see, that this is counting in binary. 0, 1, 2, 3, 4, 5, 6, 7, 0, 1, 2, etc. as it goes on, and it's changing once a second, which is in line with our clock, which is going at 1 hertz. If we wanted to speed it up and to see that working, let's go at 10 hertz. And it's much harder to keep track of. So let's take it back down. Back to 1 hertz. Right, so as I promised, I'm going to turn this into a macro rather than just leave it as it is. And in order to do that, we need to add tags. What I'm not going to do is actually remove everything in this situation. I'm going to leave these LEDs there because sometimes we might want to look inside the macro and see what's going on. So I'm just going to connect those up to there. And For the sake of my sanity, I'm going to label these with annotations, and that's um, out zeros. I need to remember that these are reversed, and I probably want to, when I do the template, change the order around. One. And paste again. Edit annotation. As you can see, hopefully, hopefully you can see that it would be really easy to make a longer counter up to as many bits as you like. In fact, for this, I'm just happening to do 3-bit, not because it's relatively simple, although that is kind of helpful, but because that's what I'm going to need somewhere later on down the line. The other thing that I want to do is I want to make it so the clock is external. Excuse me. So I'm going to need to remove the internal clock because you want other things synchronized outside your counter. So I'm just going to delete that. But I put the tag on first to make this simpler for me to do. Right, let's get the template. And so we no longer want it to be called JK flip-flop, which is what I've previously been doing. It's a counter 3-bit. And I'm going to need some of these inputs and outputs. I'm going to turn it around so the oh my god, no, let's keep it so that it goes left to right. Well, I'm going to expand slightly. So let's extend this out a little bit. These tags are quite hard to handle when they're completely embedded in the box. I don't want all of those. I'm going to take one of those tags across to the other side. I'm going to change the annotations so that's clock. In fact, we don't need 2 inputs, we only need 1 input, so I'm going to get rid of that. That letter K. I'm going to move the word clock slightly further out. Now, the reason why I'm keeping that high on that side is not because of any electronic reason or anything like that. It's simply so that I can have that word above the name here to make it easier to read things. I've got 3 outputs, and I'm going to stick an annotation on that, but I'm going to rotate it. So out, and normally you do to 0, making it vertical like that. Come on, line up. All right. So let's move that a bit closer to that. So now we need to do the wiring up. There's not a lot of this to do, so I'm not going to fast forward. That's my clock input. And then we've got out 2 is going to be the one at the top. Out 1's the one in the middle. Out 0 is the one at the bottom. Okay. Let's save this. So I'm going to save it as a counter 3-bit. And as always, let's make a little circuit to test it. So 3-bit counter, we need a clock input, which is that one, and 3 LEDs on outputs. to the clock and then simulate. 1, 2, 3, 4, 5, 6, 7, 0, 1. Yeah, so we've demonstrated that it's working. So this is nearly the end of this short series where we're using these memory cells. This is a particular use of the JK flip-flop to create a 3-bit counter, or in fact any length binary counter. The next video just kind of tidies this up by adding a little bit more functionality to the 3-bit counter. So I shall see you then, but that's it from me for now.